Okay. So let's start the journey of machine learning. So first, when we start with the machine learning, everyone will have these few questions in mind. First thing is, what is machine learning really it is? When we should use machine learning, rather when we should not use machine learning. So in what circumstances, in which situation we are supposed to use the machine learning, that we should clearly understand. Otherwise, for very small and very simple problems, if we use machine learning, we will not be able to justify, we will be wasting the power of machine learning. And that's why we should have clear idea in our mind in what circumstances we should use machine learning. And of course, why machine learning? So what, when, and why? These are the three questions that we are going to answer in short time. So starting with what is machine learning and how it is formally defined, that we should understand first. So let's go to the definitions. So this is a formal definition, the first definition that is given by Arthur Samuel somewhere in 1959. Machine learning and how he has defined. It's very simple to understand this definition. Machine learning is the field of study that gives computers the ability to automatically learn and improve from the experience without being explicitly programmed. The last 4 or 5 words are very, very important. It says that it should learn by itself. Very important. The machine should learn by itself. Here, when we say a machine in the sense here, we are talking about the computer mostly. So we want that the computer should learn the ability or get the ability to learn through the examples, learn through the experience, learn through the environment, just like human learns. So that ability, and it should, once it is programmed, it should not be explicitly programmed all the time. So once I design and develop an algorithm and use that algorithm, it is job of the computer or job of the machine to improve upon it. And that's why this words are very important. Okay. So automatically it should learn and improve the performance from the experience without being explicitly programmed. For that, I should not program again and again. Next, and simple definition that we come across in the literature, it is set of methods that can automatically detect the patterns in the data and then use the uncovered patterns to predict future data. Now this is something different way of defining the machine learning. Like we have a data. Now in data, the data are related to each other. For example, yesterday I had given you the example. Like if I have a data of the people who are residing in different suburbs of Pune city, then I can dig out some relations, like who are staying very near, very close to VIIT. So that is a relation, that becomes a relation. So on the basis of that feature, I can relate some of the examples. Examples means we call it as fields, the records. Okay. So I will be using most of the times the word as examples. Examples means it is not just an example, just like whatever we conventionally use. Example is a record. I mean, for example, I have created a data set of 100 records. So every record, every say there is a data of 100 persons. So every person's record is a separate example. So we call it as an example. Okay. So example is not the great thing. It is simply a record. Okay. So when I say that there are 100 entries in the data set, we call it as 100 examples are there. So, or we also call it samples. So these are interchangeably used words. So please remember, I have a data set. In data set, suppose there are 100 entries are there, 100 records are there, and every record we call it as a sample or example. So I will be using these words interchangeably as samples and examples. So job of the machine learning algorithm is to discover this pattern who are staying very close to the VIIT. So when I give the data set, data to the machine learning algorithm, the job of the machine learning algorithm is to discover these patterns. So it finds the pattern that yes, out of 100 records, 100 examples, 100 samples, these 10 people are staying very close to the VIIT. And that's why this becomes one pattern. So discovering this pattern and then use these patterns to predict the future data is the job of machine learning. So this is another definition that you can find in the literature, like it is a discovery, pattern recognition, okay, identification of the patterns. So how we can separate the machine learning from pattern recognition field? So pattern recognition is one of the tasks in the machine learning. And in machine learning, we actually use machine learning programs to predict something. So job is ahead. We have to discover the patterns, use those discovery, and then we have to use it for further predictions. Prediction is very important task in the machine learning. So let's go quickly towards another definition. This is the simplest definition that you find in the literature. Learning a relation between y and x. What do you mean by that? Let us understand this point. So in simplest possible definition is I can write y as some function of x. So when I write y as some function of x, this function could be known to us. It could be known to us or it could be unknown. Known function, if I give the example of say sine wave, okay, if we take an example of sine wave, let's say write y is equal to 10 times sine of x. So here why I am saying that this is output and this is some input. So when I write this is a deterministic function, and this can be very well expressed with the help of sine, because the output follows some mathematical expression which is already existing in mathematics, and very simple expression like this, where I can easily express y as say 10 times sine of x. So this is a known function. Now for this, we definitely not go for machine learning, because we have very simple functions to express. Machine learning is not for that. If I have complex data, and if I don't know how to relate this y with x, then we actually go for machine learning. So in machine learning, we are really interested in finding out the complex relation between output and input, as well as in input parameters, and discover the different patterns like we talked about on the previous slide. So in simple definition, it is a learning program. It has to learn the relationship between y and x. It has to discover the relation between y and x its own, and then use this relationship further. Once I know what is the function, so once the machine learning program discovers this function, then I can easily use this for prediction. And then if I give unknown value of x, say 1000, and if I know the function now, then I can easily find out this output. And this is what the prediction is. This is what the prediction is, isn't it? So this is what the definition says in simple manner, that it is a learning program which relates output y with input x. Okay. So instead of we writing the code, what we do in machine learning, we feed the data to the generic algorithm. So there is algorithm, we feed the data to the generic algorithm, and the algorithm and machine, or the machine learning program, builds the logic based on the given data. So it has to use the data, it has to find out the relation between data, discover the patterns, and it has to come out with the relationship which we can use further for predictions. So this is a job of machine learning program. Okay. So hope you are understanding the definitions. Okay. So what is the difference between machine learning, typical machine learning, and traditional statistical methods? So as I given you the example of y is equal to sine of x, 10 times sine of x. This is already available function. So are we going to use the machine learning program for this kind of things? Answer is big no. Okay. So very complex relationship, when the generalize or statistics fails rather to express the relationship between the data, then we take the help of machine. Okay. So this picture clears this complete concept. Okay. So in traditional statistical methods, what we do? Okay. So what we do is we first study the problem. Okay. Like we look at, for example, let me give you an example. Like suppose I have a data like this. All these are samples, sample points. Okay. Now when I look at this data, I study this data. So suppose this is X. And then when I try to find out the relation between Y and X, I study this problem and I write some rules for it. And here I come to know that y is a sinusoidal function of x. Y is equal to sine of x. All these are individual examples, sample points. data points, or we call it as examples. Okay. So for every x value, we know that we have some y value that we get with this rule. So when this